Welcome, and in this lesson, we're going to talk about Amazon Web Services Simple Storage Service. Now, a few things, basic overview of Amazon Web Services S3, but keep in mind, we're going to dive into a lot of overview knowledge and a lot of in-depth knowledge that we're going to need in order to prepare for the CSA. Now, objects stored inside of an S3 bucket is just a static file, for example, PDF, an image, are just static files that contain metadata information. So metadata information is just a set of name key pairs. It can have user-defined metadata, or that metadata can also be defined from Amazon themselves. It can store information such as the type of storage the object is supposed to be using, either Glacier or RRS. Now, buckets, of course, are just a group containing a set of information. It's a set of these objects. Inside of a bucket, we can have sub-namespaces, which look and act like folders. However, technically speaking, it's just a namespace and organized differently in the backend for AWS. Now, inside of the console, we view those and they look exactly like folders would when you're browsing a file system. Now, inside of Amazon Web Services S3, each bucket name must have a unique name across the entire AWS S3 namespace. So if I have the bucket name Linux Academy, you cannot have the bucket name Linux Academy, regardless of whatever region you're working out of. So AWS S3 is again a file and object storage. It's designed for high scalability and high availability. So you're able to have essentially unlimited or infinite amount of storage on that device. There's not storage limits when it comes to how much data you can upload. However, there is a size limit. Objects can be as small as 0 bytes and as large as 5 terabytes. Again, an object can be as small as 0 bytes and as large as 5 terabytes. It's highly available by design, so whenever you upload an object, it is synced to other availability zones. So if one availability zone becomes unavailable within your region, your data will be accessible through the other availability zone. So Amazon S3 standard storage is designed for 11 nines durability, which means your object has 11 nines durability. The chances of it being lost or going corrupt are very, very slim. And 99.9% availability, which means that's a bare minimum that your object will be accessible via Amazon S3. So there are a few bucket limitations we need to be aware of. There can only be 100 buckets inside of a single AWS account at a given time. And bucket ownership cannot be transferred once a bucket is created. So once a bucket's created, you can't switch that over to another user. You'd have to delete the bucket and have the other user recreate the bucket. Standard storage is designed for 11 nines durability and 99.99% availability. However, we can specify an RRS, or reduced redundancy storage type, which means that we're giving up some durability. This is a design trade-off, right? So if we're going to choose reduced redundancy storage, we're saying that I'm willing to pay less to have less durable storage, which means objects can become corrupt or objects can become lost. So reduced redundancy storage has 99.9% durability instead of 11.9 durability like the standard storage type. Reduced redundancy storage should only be used with data that is easily replaceable or reproducible. It does have 99.99% availability, which means it'll be accessible 99.9% of the time. Now, Amazon Glacier storage type is used for archiving storage. It's generally about 0.01 cents a gigabyte. It does vary based off region, so you'll want to check your pricing, as AWS pricing also does vary quite often. So the cool thing about Glacier is it integrates with what's called Amazon S3 lifecycle policies. So we can actually tell an object after living inside of our bucket for a defined amount of time to move to Amazon Glacier for archiving automatically. So again, Glacier needs to be used only for infrequently accessed data. You would not put data that's part of your backup policy when you need to restore or recover from a failure within a short time period. That's not what Glacier would be used for. Glacier is used for archiving data, which means data that would otherwise not be important to a disaster recovery situation. For example, a lot of times when companies archive data, they would send it out to caves and different companies like Iron Mountain in order to store this data. And it would take a couple days to store the data as well as retrieve the data. In Glacier, it takes several hours, sometimes up to a day, to check in, store the data, and check it out from Amazon Glacier. So this is why it's only used for infrequently accessed data. So with Amazon S3, there's two key components that I really like to talk about, and it's Amazon S3 versioning and S3 lifecycle policies. So versioning allows us to store all versions of an object, including versions that we've deleted and versions that we've written over. So if we create an update to a Word document, it'll store the new version as well as the previous version that had our old update on it. So versioning and lifecycle policies can both be enabled on a bucket at the same time. That actually means that we can apply a lifecycle policy to our versioned objects. We can say our versioned objects need to either be archived or deleted after a certain amount of time. This works well. Using versioning and lifecycle policies really work well when creating a backup policy inside of your environment. If we're able to store documents through Amazon Storage Gateway or is some other way of uploading to Amazon S3, we can create a backup policy with versions. We can say we want to store all versions for 2 months. After 2 months, you can start deleting versions that are 2 months or older. So that's what lifecycle policies allow us to do. It allows us to define the number of days that we want something to live, define the life of an object within a bucket. Once the life of the object that's defined in our bucket is up, do something with that object. Either delete it, remove it, or send it to archiving. And this is very cool. We're going to teach you how to apply it to specific objects with a prefix, to specific sub namespaces or subdirectories within a bucket. So let's talk a little bit about Amazon S3 security. We always need to be thinking about our environment from a highly available, fault-tolerant, cost-effective, scalable, elastic, and secure environment. That's a lot of keywords there. So just keep with me. We're inherently going to learn this as we work throughout this course. So about Amazon S3 permissions on a bucket. All buckets when created, all of the objects when inside of a bucket when created are private by default. So we have to grant permissions if we want that information to be publicly available. Access control lists allow us to actually create a method for sharing our S3 bucket with another account. So you can have 2 AWS accounts and actually share the S3 bucket with another account. We can use IAM policies to grant IAM users access to specific resources. For example, we can grant the developer group access to the developer bucket, or a specific user access to a specific bucket. But not only do we have a way of defining access to Amazon S3 in IAM policies, but we also have a way of doing it with bucket policies. Now, bucket policies are used for creating permissions like creating and granting anonymous user access, or restricting access to a bucket based off of the incoming IP address. Or we can restrict access based off the HTTP referrer. We can say only display the contents of this bucket if the person is coming from a specific website. So that's what bucket policies allow us to do. So we can almost create something like a miniature intranet inside of our environment with bucket policies. So public content within our bucket can be downloaded. Generally, you can share a URL over the internet and allow a user to download that bucket contents. Now, that's one thing we need to consider when we're working with Amazon S3. If we need to share a contents of our bucket with a user within our company that doesn't have access to S3 or a method of being VP'd in to access it, how could we make sure that data stays private, but also share it with that company employee? Well, with CloudFront and Amazon S3, we can actually create something called a signed URL. A signed URL uses a key to create a certificate, basically an encrypted key, to create a unique URL. This unique URL can expire after the designated time period. Now, we do need to do this with the API, but we can set it and create a unique URL that says this URL no longer works after 5 p.m. or no longer works 1 hour from now. So of course, whenever we're using the API, SSL has terminated endpoints. An endpoint is just the region and the AWS URL that we're accessing for uploading and downloading content. So Amazon S3 also has server-side encryption. With Amazon S3, we can encrypt an object. Either we can specify S3 to encrypt the object before it saves it on S3 partitions in its data centers. And then whenever we go to download the object, Amazon S3 will automatically decrypt it for us and download it. So it's being stored encrypted at rest. Now we can also use our own encryption keys. We can also incorporate a little bit better more with AWS Key Management Service. But if we wanted, we could upload our data already encrypted using our own encryption policies and our own encryption keys and store it on Amazon S3. That means we need to manage our own encryption keys, and if they're lost, then there's no way to access that data. So you might want to think about, hey, is this a concern, losing our custom encryption keys? Should we integrate with AWS Key Management Service? Should we just designate that AWS store the documents encrypted for us, store the objects encrypted for us? So let's talk about using Amazon S3 when architecting applications. Amazon S3 can be used for hosting static websites when used with Route 53. So if we have a static website, a static HTML page that we want to serve to our customer, why do we need to go set up an entire EC2 infrastructure, auto-scaling application, web application? Why not just upload the HTML documents, send Route 53 to our S3 bucket, and serve it as a regular website? S3 can act as an origin to the CloudFront CDN. This means we can store our PDF files, our static files, our images inside of Amazon S3. Then CloudFront can actually pull the documents from Amazon S3. That's what an origin is. We'll learn all of this in our CloudFront section, and serve it over the content delivery network cached around the world in the edge locations. Then when it comes to uploading S3, let's say that we are building an application that utilizes S3 for data storage in the background. Well, we could use what's called a multi-part upload. So it allows for uploading objects and parts, which means we can actually program it with like the Python SDK to upload this concurrently or in parallel processing. So our upload speeds can actually substantially increase. The multi-part upload will break it apart and concurrently upload it. We can also stop and start file uploads. So if we wanted to stop a file upload and resume it later, because we're uploading specific parts, the multi-part upload API to Amazon S3 actually allows us to do that. That's very cool. Now, the multi-part upload is required in order to upload objects that are 5 gigabytes or larger. However, it is suggested to be used for objects 100 megabytes and larger for speed purposes. And if we were using the console, we wouldn't be concerned with this because AWS handles this on the back end if we're using the console. However, we can use it with the SDKs and the command line interface. So let's talk about our data when it is uploaded to Amazon S3, our objects. When we upload an object, the object stays within the specified region that we upload to in Amazon S3. It is then synced across all of the availability zones within that region. That makes for high availability and fault tolerance. However, we do need to be aware of something called eventual consistency. Now, for all new puts, which means you're uploading an object or you're creating an object, if you're using an SDK, for example, everything has read after write consistency, which means if you upload this object, if you create this object and you turn around and instantly make a request to read the object, regardless of what availability zone is returned on your request, because again, you can't specify an availability zone, you can only specify an S3 public endpoint in your APIs, then your new object will be available. However, eventual consistency does come into account when we're overriding existing objects and deleting existing objects. So those are put API calls and delete API calls. So for example, please note that this applies to all regions going forward, right? So all regions now support read after write consistency for puts of new objects into S3, and all regions use eventual consistency for puts overwriting existing objects and deletes of existing objects. So for example, if you overwrite an existing object and then turn around and instantly, a split second later, make a request to read that same object, there's a chance you're going to be getting the old version until eventual consistency applies all of the updates to each availability zone within the region. So when should we use Amazon S3? Well, anytime we're designing an application to host static files. If we are serving images, CSS files, PDF documents, Word documents to a web server for our web application, or when we want to back up for disaster recovery in our on-premise network, we can use Amazon Storage Gateway and use S3 as our actual file system. S3 is automatically backed up, and by enabling versioning, we can have our own backup policy on top of it. We can host static websites. We can set up file shares inside of our EC2 instances for networks. Some applications actually use something called S3FS, which mounts S3 as a file system. Now, that is debatable, and one thing you need to think about as an architect is the latency of reading and writing. So that's just something that you'll have to test when you're designing applications. And of course, we can use it as an origin for our CloudFront CDN. And in fact, we're going to do that later in this course. So we can upload files to Amazon S3, enable a CloudFront distribution, and have a global content delivery network that caches data in data centers around the world, called edge locations. So let's talk about something called event notifications inside of Amazon S3. And in the following lessons, we are going to go look at all of these things inside of the console. So an event notification is sent when a specific event or action occurs against the bucket. So for example, let's say that if you have reduced redundancy storage, RRS storage enabled on an object, which means there's a chance that because it has lower durability, your object could be lost. And let's say that object is lost. What do? Well, as architects, we don't have to be completely concerned about that because AWS automatically recognizes a lost object and sends an RRS object lost notification. When it sends that RRS object lost notification, we can subscribe to it or have it sent to multiple places. For example, we could create a simple notification service topic. We could use and integrate with Lambda, or we can send a message to an SQS All three of those services allow us to write automation. For example, if we have an SNS topic, it can automatically hit a website, which recreates the object. If we create a message in the message queue with the object that's lost, it can take the information from the message queue and recreate it, go through our worker instances, recreate it, and upload it to AWS. Now, of course, we have to write that automation. That's outside of the scope of this course. We cover that in the AWS developer course. So the notifications that are available are the RRS object lost and object created. So the object created applies whenever we are using an API. That could be the console or API through AWS command line interface or an SDK. So whenever we're uploading, we can either use put or post for upload, copying an object, or whenever a multi-part upload is completed. Because whenever a multi-upload part is completed, whenever you upload all of your parts that we discussed a minute ago, the API call called complete multi-part upload is completed, and it can send us a notification, which we can then send to SNS, Lambda, or SQS and integrate with our automation infrastructure to be notified of objects. So if you're getting kind of an idea here, is we can use the simple notification service, the Lambda service, the SQS to write automation in our infrastructure. Once something is done and occurs, go ahead and move over to the next thing and glue components of our infrastructure together. So that concludes it for the essentials lesson. Go ahead and complete this lesson and move on.